G'day, it's Charlie ZL2CTM. I had a request in a previous video, or just a recent video, to provide a little bit more insight into the approach I take for the various modules and for building the radios. I guess in an effort to try and provide, some more insight into what I think and the approach I take. So this particular video here, there's going to be no real structure. It's just going to be, once again, me sort of just talking about what I'm about to do with regards to this radio. It may be of interest to some. If not, otherwise just skip the video. But otherwise, like I say, I'm just going to have a bit of a chat about what I'm thinking and the approach I'm going to take before getting into it. I've got a few business trips coming in, so it's going to be a sort of bit of juggling backwards and forwards about getting it done, but I'm certainly looking forward to getting into it. So I guess as a start, maybe just look at the a block diagram, and we'll go from there. So as I said, this is going to be a CW rig only at this stage, just to, well, it will be only a CW rig, just to force me to become proficient again in CW. I do want it to be at least 80 meters. I like 80 meters for the local contacts here, and I know that there is a quite a good little CW group there for practicing, so definitely 80 meters, and then why not also look at 40 meters. And when we look at the block diagram, I'll talk about what I intend to do for that. So the way I'm going to approach this, it's going to be from a receiver point of view, block diagram. It's going to be centered around a filter. Now the filter itself, I'm just debating about using a commercial one or Homebrew. You'll see over the back here, I did purchase some time ago, I'm tempted to say it was around 50 9 megahertz crystals from, I'm pretty sure it's from AliExpress. I took some time to go through those and determine what the individual frequencies were, and from that I actually did build some filters a year or so ago, but I did have quite a few left over, and as you can see here, there are only 4 in each stack, but this group of 4 here is 21 hertz difference between the highest and lowest frequency, 35, 30, 25 and 16. So what I'm tempted to do is to try making, for a start, for interest's sake, a Homebrew CW crystal filter using one of these sets here. I'm just debating whether to use the 16 hertz set, which I think I will, and try and get the pass band to be, sort of approximately 200 hertz, I suppose. Might be sort of a start point. This is one I did make a while back. It's got six crystals. I might have another look at that one, put it through the VNA and just see what that come out, or see what that looks like, more the point, and maybe rebuild it. The strip board, I acknowledge, is certainly not the best. You can't quite see it there in the picture there, but I did actually remove virtually all of the copper using a little drill, so that sort of parallel capacitance between the tracks I try to minimize as much as I can. But I may look to sort of desolder all of those and put them onto a piece of copper board and have a play, or maybe just set this aside and start again from scratch using this group here. If that turns out to be a total disaster, then not all's lost. I do have this old, albeit 3.9, say again 3.3 kilohertz filter lying in the junk box, which I could use if need be. But like I say, for a start, I'll look at building a Homebrew filter. So like I say, it's going to be based around a filter of some sort. If it's Homebrew, that'll be 9 megs would be the IF. On either side of that will be an IF amplifier. From an overall, what I'm thinking is, as I've done in the past, from the antenna down this end all the way through to the speaker, going to be needs somewhere in the region of 100 dB of gain. So I can definitely see probably some kind of antenna amplifier coming in, albeit with 80 meters and arguably with 40 meters being less than 10 megahertz. in terms of operating frequency, that the need for this particular amplifier here is not so great. Noting that I'll be amplifying both the signal and the noise as it comes through. But in terms of trying to meet the overall 100 dB gain, that will be of use. So I don't see that one, because I am amplifying both the noise and the signal, being overly high gain, but it'll be there nonetheless. And then the two IF amplifiers, I think just to keep things nice and simple and to use components that are readily available, they will once again be the 2N3904. For, those amplifiers will be based around that. And then the audio amplifier is very much a TBC. I'm not quite sure if I go for integrated circuits for that one or go otherwise, but that'll be the generic breakdown for the receiver. So single conversion, RF coming in, that'll be mixed with our variable frequency oscillator, producing our IF. That'll be amplified through our crystal filter, like I say, somewhere in the region, if I can get it down to that, would be quite nice, of say 200 Hertz for a pass band. Second IF amplifier then into our product detector, being mixed with our beat frequency oscillator to recover our audio. I think for the audio frequency for the CW, I'm going to aim for a say 700 Hertz. It seems to be a frequency I'm sort of settling on now as a CW tone, but like I say, I'll do a bit more practice, see what's nice to my ear, and if it needs to change, then that's certainly easily done, which will be covered in certainly later videos. At the moment, my little portable CW rig is set up for 700 Hertz for the CW tone to be on frequency. So like I say, single conversion there, one conversion down the IF, and then a second with the product detector down to our audio frequency. Right, so in terms of the oscillator itself down here, once again I'm going to use the SI5351. Why? Because you know, I have quite a few of these in the junk box. They're nice and easy to use. I find them nice and stable. They really are quite cheap, so you know, why not? I'm comfortable using those, so I'm just, you know, more than happy to use or to keep on using those. Now, what I'll put it sort of just branched, and I'll probably go backwards and forwards between the transmitter and the receiver. What I am going to do, I'm going to utilize on the SI5351, clock 0 is going to be the VFO. Clock 2, so the furthest one away, is going to be the beat frequency oscillator. I'm not going to filter those, so I'll just keep those as the square wave outputs, driving those mixers there, which actually is an interesting topic now. So in terms of the mixers themselves, I don't think I will build those from scratch. They will be double balanced mixers. I'll probably either use the Tough one or an SBL one, or was it Tough 3, I can't quite recall. Probably a pre-packaged mixer for those two at this stage, but you know, things change. So back to the SI5351 here, and clock 1 I'm going to use for the transmitter. So what I mean by that is, so this is our receive side. On the transmit side, what I'm currently thinking, and remind me to come back to talk about the Arduino for that. For the transmitter, what I'm going to do there, I'm going to have the SI5351. I'm going to take that clock 1 output. Clock 1 output, I'm going to filter it, and I'm going to ideally turn that into a nice sine wave, so square wave out of the SI5351. I'll turn that into a nice sine wave, and then that'll go into whatever stages are required of power amplification. So the output of that SI5351 is going to be at our operating frequency, and then I'm going to amplify that, and then through the TR switch, the antenna switch that will switch the antenna between the transmitter and the receiver, out it goes. So just to recap, from a transmit side of the house, it's going to be pretty straightforward. SI5351 outputting a square wave at the frequency of operation, and filter it, and then straight out through the amplifier. Now, what I am going to do is I'm going to leave the I'm going to leave the receive circuit here on during transmit. Now, what that will allow me to do is the switch, there will be, as the power goes out the antenna, the unused connection for that particular switch, which would have gone to the receiver, there'd be enough little leakage across there for that RF to then go through the receiver to output a tone. So all things being set up correctly, if I transmit at a frequency that gives me on the receive side as effectively side tone 700 Hertz, then I know from a frequency point of view that my transmit frequency is going to be spot on my receive frequency. So effectively I've zero beated my transmit and my receive. So again, from a CW point of view, to minimize wastage of band space, you want to try and transmit on the same frequency that you are receiving and not offset. So this is the way I'm going to do it. So I'll, like I say, when I go to tune this all up, I know I want to have 700 Hertz based on a certain frequency being received, and like I've just mentioned there, if I set up the transmit frequency to give out that same 700 Hertz as side tone, because I'm going to leave the receiver turned on, then I know then that I'm transmitting exactly on the frequency that I was receiving. So that's the plan, and that's what I'm currently thinking for the transmitter. Now, straight away, that leakage there across that relay switching the antenna between the transmitter and the receiver is going to cause the poor old receiver to go hard out. So I will be switching in through another little relay, some attenuation on that signal. Not sure where I'm going to do that. I did with that portable CW rig. I attenuated, because it was very low power, I attenuated the audio as it came out of the amplifier and just sucked some of that to earth to produce just a nice audible tone for side tone. On this particular rig here, because I'm going to be a lot higher power, what I may elect to do is throw some attenuation in down here just to knock that transmit signal down so I don't overdrive the whole receiver circuit. So that's a bit of a TBA, and we'll see how that one plays out. Now, I did mention before the Arduino. Well, I'm going to use an Arduino to drive the SI5351, and what I have over here is a well, more the point, I mentioned in the video when I first introduced talking about the CW rig that I was going to have a decoder for CW just to do a bit of practice as well. I've got a program here which is just sending some code with the computer speaker, and if I was now to feed that into the decoder, it's just going to tune up to this software here was developed by Bud Churchward, WB7FHC, so all credit to him. What we have here is a little CW decoder I made up some years ago, which is using the NE567, if I recall, a DMTF chip that was popularized for that. And using a variable resistor on one of the pins, you can set the frequency that it's looking for. In this particular case, I've got the output frequency set for 700 Hertz, and now that it's tuned in, every time it passes through and it detects a 700 Hertz signal, the output goes high, the LED comes on, and then that same signal is being fed through the Arduino into the software that's running from Brad, or from Bud, my apologies, from Bud. What I plan to do is I'm going to port that same software into the CW project, but what I am going to do, I'm going to modify the code that only it only utilizes 3 lines. Ideally the bottom 3 lines will scroll. The top line up here will be the frequency. So it'll be the frequency I'm tuned to and whatever the tune step is for the rotary encoder. And I think having 3 lines there dedicated to just keeping an eye on both the transmit and the received CW should be more than sufficient. So that's the plan, so I have to do some modifications on that. That'll probably be my first project, is to play around with that. I was thinking about pulling this whole decoder apart and reusing the parts. I may still do that, but at this stage I probably might just put it back in the junk box for another day, because I do have some other spare displays and Arduinos lying around which I can utilize for this project. But that software is really good. So if the speed changes, it takes a few characters and it fine tunes itself to the speed that's coming in, and generally speaking it works really well. So anyway, let me just close that down. That's what I'm thinking there, is to, like I say, have that decoder utilizing the spare cycles in the Arduino when I'm not changing frequency. And I can see, using the same code as I've done before, it'll be an interrupt driven routine that every time I change the rotary encoder, an interrupt gets flicked, it'll run array, change the frequency. I don't care at that point in time if it's not been decoded, that's fine. Which should jog my memory. I'm thinking about what's the best way to incorporate this decoder into the project. Part of me is thinking about, we'll just utilize that same tone decoder chip there, which is a very simple circuit to feed that signal in. You've got the LED there, which tells you when you're on frequency. So I'll do away with this rotary switch. So again, this variable resistor here, I'd replace that with a fixed value resistor, which would then have this chip here tuned to 700 Hertz, which, if you recall, is what I'm after back here for the overall radio. So that would then, by virtue of that LED coming on, would indicate to me that I'm on frequency, and if that's the case, whoopsie daisy, apologies, when I go to transmit, I'll know then I'll be transmitting on the right frequency. So that's one way of doing it. I may have to put some thought into if there's any other suitable way of detecting that frequency that's coming out of that product detector. To be 700 Hertz. So, but I think, like I say, that chip is very cheap, so I think I'll probably just utilize this circuit here. I'm pretty sure I've got another one of those lying around somewhere. So that'll be good. So that, like I say, that'll give me that tuning one. I was initially thinking about having some kind of little bar down here that would move backwards and forwards around my desired 700 Hertz. So if I had a line up here, then I knew I was slightly high in frequency, and conversely, if I was below the line, I was slightly low. I'll just think about that one. But like I say, I think it's just, I'm starting to ramble here a bit. I think it's probably just more convenient to use this chip here. What else did I want to cover? So yeah, from a power amplifier point of view, 2 things I want to play around with there. So on the transmit side of the house, I do want to revisit this little circuit that was made up some time ago. These are BD 139s in parallel with their emitter balancing resistors down there. So I do want to look at a QRP version. I want to strip off all of the biasing. Being a CW rig, I will play around with a Class C bias, so I won't have any quiescent current flowing through these transistors with a no signal condition. They'll be biased just below cutoff, and when the signal comes through, they'll conduct. So I do want to play around with this particular circuit, and then I'm also tempted to, if I can get it without dropping anything, excuse me, I might also think about playing around with this. So this is, you may recall that from a video from a year or 2 back. where this came out of an old marine radio where I had stripped off a lot of the biasing from these transistors here, the driver side here, then the power amp on this side, to play around with some simple biasing as an SSB amplifier. I'd look to strip that all out again and convert it to a Class C amplifier and just see where that goes. So I'm thinking about also playing around with that to give a lot more power than I'd ever get out of those parallel BD139s. But you know, my interest here is more QRP than trying to get around the world. So yeah, we'll see how things play out there. But again, the whole idea of this video was just to sort of talk about what my current thinking is, and that's where we're at. Which sort of, again, there's no structure to this video, so I'm just sort of talking out loud here. In terms of impedances, again, I'll determine those as we go along. The dBm is going to be 50 ohms in and out, so that makes it nice and easy then to set what this amplifier's output impedance will need to be, as well as the IF amp's input impedance. The crystal filter remains to be seen. If we end up going commercial or homebrew, we'll have to determine what its impedance is, and then develop the output transformer and the input transformer for this amplifier to suit the input and output impedance of that filter. Again, 50-50 for that BFO there, and then on the audio side, so that's important. Well, we do in terms of matching the speaker to it. Yeah, so I think I might just finish that there. Like I say, apologies that it was a bit of a ramble, but you know, that's how I sort of do a lot of these videos. It's just more me talking about what's sort of going through my mind and what I'm thinking. In terms of steps and what I want to go next, what I do want to work on first is the Arduino and the SI5351 and the decoder side of the house. So it'll be this part here first, bit of software engineering. Get that to do both driving the SI5351 all 3 ports and having that decoder working nicely on the bottom 3 lines. So that'll be step number 1. I can sort of see after that, yeah, not quite sure if I want to go on the transmit side first or on the receive side. Probably the receive side first. I can see, you know, build the audio frequency amplifier. Then you can use a test oscillator here to feed into that to test the output, just to confirm that that's working, and then probably work on the antenna amplifier and work in towards the middle before putting it all together. So we'll see how that plays out. But again, it'll be in modules. That'll be a module, that'll be a module in its own right, and then it's just a matter of linking them all up, as we've seen in the past, to get the overall radio from the receiver going, and then the transmitter. Once again, I'll build this on a big piece of wood because that's how I like it. Makes it nice then to play around and to pull things in and off, and the like. That's what I like. I like to be able to see the components and what they do. It's just, yeah, it's what interests me. So that's what I'm going to do. Okay, I think I've said enough there. I'll put this on up and shift, like I say, my attention to doing a bit of software. See if I can get that sorted out today, and we'll go from there. So normal story, I'll just keep putting up individual videos, and I'll also, anything I do produce, be it code, circuit or schematics or whatever, I'll put up on the blog, which if I remember, I'll put in the show notes, all the tags. So that's where I'll deposit everything, and we'll go from there. Okay, 73's all. Have fun, and we'll talk to you soon. Cheers.